Yeah, sorry. So I forgot to record the session, so I needed to start. And then, okay, yeah. So I was saying, like, you first generate the Gaussian kernels and the derivative of it. Do the math on the notebook. It's simple. Use the NumPy function. You will be able to get it online as well. And then it's pretty easy. The third step is to convolute the image with these kernels. So you need to perform the convolution as mentioned in the PDF, like along two directions, X and Y. So first you will have the original grayscale image, then you will do the convolution with the Gaussian kernel, and then you will get uh, a derivative on the X and Y direction, like an output in X and Y direction, and then you will use that image for the like derivative with the Gaussian kernel. And just remember that like the input is h cross w cross c, and the kernel shape is like something like h cross w. So to get the final output image as the same input image shape, you need to apply some padding. So just take care of that thing, and then like perform the convolution, get the derivatives, get the final image. You will get two image in the x and the y direction, and then you will see that in the PDF there is that fifth step, basically calculating the magnitude of edge response. So yeah, there is a function in, again, NumPy, that you can directly use it to calculate, given that you have both the x and the y derivatives. And then finally, once you have that image, then for the non-maximum separation, you like calculate the gradient orientation. So as mentioned in the PDF, there is arc10 function, which is again in the NumPy. So you will be pretty much using a lot of NumPy in this for all the functions that you need to use it for the assignment. NumPy is the one. And then okay, yeah. So you perform the non-maximum separation for given magnitude and orientation. Uh, And then, yeah, so as mentioned in the PDF about the details of the like non-maximum separation. So when you consider the pi, so pi is like a 0 to 360. So just remember that when you are checking the gradient computation, like to compare against the value from the neighborhood pixel, you make sure of checking it along the four uh, pi phases, like 0 to 45, 45 to 90. So, and then like just keep in mind about those angles. um, and then you will get like the output with this NMS applied. So the magnitude and the orientation, what you need to like, this is I think the main crux you will where you will it will be difficult, I guess. So just keep in check. I cannot have more details. Like I can help you with it, but I cannot release a lot of details because this is like the crux of the assignment as well. The final step is the thresholding. Thresholding is kind of an easy step. It's not that difficult. So it is like you can select your own high and low threshold value, whatever you want. And then you do adjust that thresholding with the image parameter. So let's say the image will have something of like a minimum value. So you need to adjust your threshold values accordingly such that it does not overshoot, or like it's not below the value or something of the image what you have selected. So this is just like adjustment of the values. And then the next step is just like if the value is greater than both, then like it's a strong pixel. If it is not, then it's a weak pixel, and the other is like an intermediate value in between. So firstly, like you connect all the weak with the like assign all the weak which are connected with the strong as like edges, and then finally whichever is like the weak pixels which have like less than both, remove those pixels. So and one more thing, like in the PDF there are like six images that you need to save while submitting the report. So while saving the images, try to keep a check on the magnitude. So in between that you will shuffle, like grayscale would be, I think, yeah, 0 to 1. In some, like you will apply some scaling something so that it is the values are between 0 to 1 for your operations internally. But then when you're saving the images, just remember it to multiply it by 255 and like use int 8 such that the images are generated properly while you submit the report. Um, and like there are one or two questions that people ask. So you can use like instead of using this mentioned um, IDs, you can use Google Colab as well, but just download the code in .py format and then submit it to us. And yeah, that's basically it from my side. But then, like, I mean, you have if you have any questions as such in any step, you can ask. You guys can see my screen though, still, right?
Yes.
Okay, cool. And yeah, just some screen changes. Yeah, you guys can ask questions if there are any as such for some part. I will try to answer it if I remember everything correctly. If I don't, I will get back to you. Or if there's some general concern, something like that, then I can take that as note and then I can post it as like an announcement too. So yeah. Yeah, the session is being recorded. I missed a little part of it in the beginning to record, but then the in the beginning it was just I was talking about how to generate the kernels. So like generating the kernels, it's basically just a little bit of maths. I mean, you know the equations, so um, it's NumPy all the way. Everything is NumPy. You're not allowed to use any functions as such. I think at one place you're allowed to use it, so you can use it over there. But then most of the assignment, everything should be in like if you're using it, you should be using NumPy. So in the beginning, I just mentioned how you generate the kernels. So that was mostly it. But then yeah, you can. The recording is there. Okay. I'm not sure. I can check with Dr. Rawat about the library function for hysteresis thresholding. Uh, yeah, I'm not sure because the earlier when I was in this course, I submitted the assignment. I just you can just use for loop and then find out. It was basically you need to find the for hysteresis thresholding. I'm not sure what function actually do you need for hysteresis thresholding. You can check online if there is if there is some specific function for hysteresis thresholding. But basically, what I did was I just followed these steps, and it's just basically two for loops across the image, and you check each pixel value if they cross the threshold or not cross the threshold. If they cross the threshold, then you assign strong, otherwise weak. All the everything else is intermediate. Then you just check it again, like which are the weak pixels which are connected to the strong, and keep those pixels like because those are the edges still like connected with strong pixels. And then the third step final is like removing of the weak pixels at all, like which are lower threshold. So I did not use any function, but I can check with Dr. Awat if people have used something in earlier like sessions for this course for this assignment. Yeah, you need to write the convolution and padding yourselves. Everything above hysteresis, it's like, so the question is the part to write the convolution and padding. So yeah, you need to write it on your own. So padding is just like adding some pixels on the side of the images. So it's it's not a difficult step. So, but the thing is, you know that like if you take an image and then when you run the kernel all over the image by sliding it. So at the corner, it will for all the 9 pixels, it gives the one value after convolution. So that corner thing will get reduced to by h minus one, w minus one, something like that. So you just add it on top based on your kernel size is 3 cross 3. So you know that that one size will get reduced. So you pad it by that. You pad the image by that much amount such that the final output image remains the same size as the input image. That's it. Do we use this formula to calculate the kernel size? 6 into sigma plus? Um, not really. Um, where does this came from? Like, is this something mentioned in the book or something? Like, for the kernel size, I mean, kernel size is generally 3 cross 3 or something like that, right? Are you talking about value or talking about just a minute? Yeah, you can select the you can select the sigma with that thing. Yeah, that's right. Yeah, that's right. Yeah, the 6 into sigma plus 1. That's right. Sorry about. How how is the hysteresis threshold image supposed to look like? Okay, I can generate and like, so you are talking about how the input and the output should be for the hysteresis. Like, okay, so like it's hard to just explain it like that. Visually, I can be able to show some images or something. So okay, it's more of like, I mean, you can actually visualize it yourself as well. Um, uh, so I mean, the thing is, it's more of like removing the weak edges, which are like not edges, which are like noisy edges, which get detected. So I can post like in the announcement as in like what it looks like, maybe sample just to um, like help you out how it looks like before and after. But it's like yeah. Yeah, this is the, I mean, this is the right thing, the hysteresis thresholding that. So what is the question again? Like, what are you asking about it? You can unmute and talk to me as well. It's fine. Which one do we use? You can use the four connected component. It's fine. You can like, I mean, it's whatever it is, you just need to mention it in the PDF. It's fine, whatever you use. There are multiple, then you can just mention it in the, while writing the report, you can just mention it. It's fine. Will there be an exam review before the midterm? I need to confirm the details for the exams with Professor Rawat. I don't know honestly. Sorry about that. I need to confirm the details. Yeah, you're welcome. So, as like I think Adam mentioned earlier, for the kernel size, this is like 6 into sigma plus 1. It's like a commonly used kernel size. So you can maybe try to follow that. You can check. I think it's so the kernel size is more of like how much filtering you want to apply. So you can you can use that and also compare with what you are using 3 cross 3. So just yeah. It will be like a 7 cross 6 plus 1. Yeah. Sigma is generally 1. So 7 cross 7, something like filter size. So 3 cross 3, 5 cross 5, 7 cross 7. These all are like any odd number works. So you can use them. Mm, for- like for padding or convolution, there is a formula. I think I'm not sure if it is in the slides or not, but then this is like a formula that you guys can use. Says that like how it will be the size. So based on that, like what is the size you need, what is the input size, what is the filter size, what is the stride that you are using, and then calculate the padding value that you need to do on the sides of the images. So yeah, like just I can share this link if you guys want, but then it's like a you guys can just Google search as well. So let me know if you want me to share this link.